Okay, finally ready with the setup. Hello everyone, thank you for coming to my talk. I'm Anton, I work for Bumble. We make dating apps, help people meet each other, significant others, build families, and also find friends. And today we're going to talk about design systems and how they keep all the workarounds, the UI organized and very efficient and optimal. So let's take a look. We'll start with the definition, of course. Then we will see how can one build a design system with Jetpack Compose, because it's the most modern UI framework for Android, maybe besides Flutter, with very similar in terms of utility. And then we will compare material design implementation, which comes from by default from Google, and custom UI, because it has some benefits for us. Then we will try to design and see what kind of the lessons we learned while developing our own design system, and see how we can design the perfect component API. Of course, we'll have to test it somehow. And the best thing, I think, in this talk is going to be the automation part, because it brings everything together and makes it really work and shine. So, what is a design system? Basically, design system is just a set of rules and tools that help you design your application UI. It just organizes everything, makes some restrictions, makes some limitations, but at the same time, it makes everything consistent. Usually, main parts of design systems are tokens. Basically, just every single property of your UI is defined by token. Most of the main use cases are colors, sizes, like corner radius, spacing, padding, etc. And everything on the UI level, every single property should be controlled by tokens. Of course, the text styles, also text is a very significant property of the UI. Assets, icons, pictures, etc. And the main thing is the components themselves. They're built using all those tokens, and then we show them and combine them together. So, Anton, you can ask me that our project does not have the design system, it's working pretty well. Why do I even need to adopt the solution? Why do I even need the design system? Let's take a look at a typical small mobile development team. We have usually 3 people, one designer which works in Figma, UI design tool, of course Android developer and iOS developer. And everything starts with the designer. They have overall UI vision, what's supposed to happen with the UI. They work in Figma, just draw elements and apply some properties to it. But most of the times they're just custom in-place elements, and all the properties are defined just as an exact value without any naming, just put it over there, change the corner radius, there we go. And when, for example, Android developer goes to Figma for the design handover and start implementing the UI, usually what they see is that it's a bunch of hard-coded values without consistent naming and styles. So to implement it on the client side, they have to take some decisions by themselves. First of all, they want to decide whether they're going to mirror the design implementation in Figma and make it just in-place thing, or like reusable UI component extracted to somewhere. Of course, they have to decide whether they want to hard-code the properties of the UI or extract them to the resources, for example, in Android. And they need to decide how to call those resources, how to call those components, basically define the naming for them. And maybe some other developer in the team already took those decisions, and they need to know maybe there is already ready to use a UI component and they just can use it instead of creating this again. But maybe not. It's not unclear, they have to read the code and see what's actually in there. They have to keep thinking about it. And developer number 2, iOS one, have to take the same decisions, but the outcome of these decisions could be different, because it's a different platform, it's a different person, they are not aligned with the previous one. And this team is quite small one, so it's not a big problem, because they can always talk to each other and figure out somehow it on a smaller scale. But when you start to really scale the company to tens of hundreds of developers, a lot of people, it starts to be impossible to maintain. Because, first of all, on the development stage for the design, different designers have different approach for designing the screens. This means that different properties are defined in a different way. When developers implement the screens and the features, they take different decisions. Of course, we have a platform impact on it, so they make different decisions because of different platforms. And even within each platform, we have different UI frameworks. Like in Android use, we have Android use and Jetpack Compose, and they work in different ways, which means that developers could develop UI differently. And it brings a lot of inconsistency across the whole code base. And overall, it could be the case that even with all those differences, developers implement the UI. But the problem starts to begin when you decide to change it. So let's say we had a green app and we decided to do a redesign, rebranding, or update some properties of the UI and make it a blue app. If you skip all the steps before and just hard code everything, or extract the different values, but it's going to be in different platforms, which means that on every single platform, on every single screen, developer has to go manually look at all the properties and modify them by hand to make consistent with the new design. And this is going to be a lot of efforts on the big code base. And in our use case at Bumble, we have multiple applications, like for dating, for finding friends, and Badoo. And in them, we share the code, which means that not only you have to modify all the properties in one application, but you have to do the same consistently in a different one. And at this point, it becomes a huge complexity issue. It's just an explosion of everything, and it becomes too impossible to maintain efficiently. So design systems come to save the day with the consistency, alignment between platforms, and easier daily decisions, because designers and developers and everything have to agree on the naming, on the styling, how we call everything, organize stuff. And then when you implement a new feature, you just already know, because there is a component which names button. In Figma it uses special defined style, so you don't have to think about it, you just follow the design and you already have the same code on the client, you just use it. And of course, the consistency of the organization allows automation, which saves a lot of efforts. And by automation, you can apply some changes almost immediately and on all platforms at the same time. So while developing UI system for design, ideal flow for the UI modifications would be like that. Designer updates some property in Figma, presses one button, and then those properties are automatically applied to all the platforms without any needs of the Android development and manual results. And this would be our idea flow. This is what we want to achieve in the end. And now let's start to see how we can implement it with Jetpack Compose. So, Jetpack Compose, modern UI framework. It's been a couple of years already since release, so we started to adopt it. It's very nice, but has some issues. But we are not going to talk about them. We're going to talk about the cool stuff. And the main thing while building the design system with Jetpack Compose that you have to learn about is local composition. Basically, all the UI hierarchies in Jetpack Compose look like that. You have a root function called app, and then it calls another function, it calls another function, and calls another function. And all of those functions build your app UI hierarchy. And what happens if you want to, for example, configure the color of the heart, which is somewhere on the bottom of the hierarchy, as red color? Without some hacks with Compose, you would have to pass it explicitly as a parameter. You have to pass it on the root, then on the next level, then on the next level, then on the next level. And eventually you are going to have your parameter delivered. But it means that on each stage of your UI, you have to explicitly pass those things. It's very inefficient and pollutes code with not really useful information, but we still want to configure those properties on the app level. So, what do? We just pass it implicitly across the whole hierarchy using local compositions and composition locals, basically the same thing. So to do this in the code, we have to define first composition local. Basically, it's kind of like a global variable which you can redefine somewhere in the middle of the hierarchy. And then to assign some value for it, we use this providers function, which says that for this global variable, we provide this value. In our case, it's a local hard color, and color is going to be red. And then somewhere down below, within this UI hierarchy, we are going to be able to access this property and read the value using field.current. And I think about composition locals as kind of a map, our hash map, which is composition local is a key, and value for it you can provide yourself. And not only we can define them ourselves, but also Google by default provides some utilities, like for the context or the lifecycle owner, so you can access those things within the composable functions without having to actually pass them from the whole root hierarchy. But there is a catch with the whole thing, is that it could be very nice and easy to use and convenient to pass every single thing in your app UI through the composition local, but you have to be careful, because those things are not the DI framework. You cannot pass your feature developments, the dependency through them, because they are not compile time safe. Which means that you can somehow forget to provide one of the composition local values, and then on production you'll get a crash because you forgot it. And until you run the screen and actually validate what happens in runtime, you will not be able to check it. So you need to be very careful about them and carefully use them. So, for design system, what actually do we want to provide on this composition local level? What we're going to configure? We're going to configure tokens. Tokens is also properties for UI. So to provide them, we should need to define them first. And we do this using this interface called tokens. We write them ourselves, but then actually in our system, we just generate them automatically from the specification on Figma. So the interface token has a lot of properties, and basically each of those properties, for example, action cell tokens, is another class which defines all design tokens for a specific component. In this case, it's called action cell. And inside we have like DP, colors, etc. And then we can just combine the interface and this class and provide the implementation of it. Basically assign the actual values to those defined properties. And then provide this class for the rest of the UI to use. Another thing that we discussed is the text styles. So for the text styles, we don't even need to implement some new classes because Compose already defines them. It's a huge class which can configure basically every single property of your text. So we just define them and provide what's needed from our tokens. Group them to the class called typography. Basically, all the default text styles which we have in our codebase, like headers, paragraph, etc. And then we define the local composition, the composition local, which we already know about. So we assign the value of the product tokens for it, and then somewhere within the team, we can access it. And to avoid some verbose code, we can even provide a wrapper. In this case, we call it tokens. Basically, it's a wrapper property which lets us write instead of local tokens.current.something.something, we can just say tokens.something. Much easier and looks good. And we can go even another level for it and access, for example, tokens for colors and provide a specific global variable for it. Very nice. Then we need to create this composable function called team, which defines all the values and brings everything together. So for this, we receive a parameter of the token values for us and typography, and then we just map it using composition local provider function. And in the end, how do we use it? We just need to define a team which sets up all the values for using, and then within our component, we can just access them, for example, using colors.brand.primary, and all will be assigned correctly. And as I've shown on the example with the multiple apps, we could have the same UI, the same code, everything the same, just different team configuration. And it means that we have different values from the properties, and we could drastically change the appearance of our application. For example, change the brand. And the only thing we need to do is just to provide different values. Okay, But you may ask me, Anton, why do you need to implement custom design system? Because we already have one. We are Android developers, we have material design from Google, it's very nice, convenient to use, and they already provide those tools for us. Why do we need to spend some time and try all this code by ourselves just to have another design system ready to use? Let's figure out why. So, let's take a look at Material. Material is a very generic design system, I would say. It builds for millions of users. So Google developed it for us, Android developers, to basically design any possible project for Android and even different platforms sometimes. It's designed to be very flexible and fits the need of every single team because there are millions of projects, millions of Android developers, and they're creating them for everyone. And at the same time, it's pretty opinionated because material design has its own rules, and those rules are not always the same as our design. So we need to do something about it. And I would say it's mostly platform specific because if you design an Android app, it usually runs material by default, but if you want to run iOS app, it has iOS appearance. So you cannot reuse it on your design level. But in our case, designers want to have a similar UI and specific brand, which is not always material. Let's take a look how they write code in material design. And one of the most important things which brings this flexibility of the UI, which allows million developers of user apply design, material design to their use cases, is a thing called slot API. So in this case, we have a small code for the button in material design, and main function here is the content. Basically, instead of describing which kind of properties each single button could have, they just said, you can provide any content you want. You can put anything within this button borders, instead of saying like, button should have text, should have icon, and that's pretty much it. Material allows you to put anything. Usually, it's going to be still text, because button without text doesn't really make sense. But it's super flexible. So what we can do, for example, is to have a button within a button within a button within a button, and nobody can stop us. But at the same time, do we really need this flexibility that much? I don't think so, because when we work on our own UI, we already know all the rules, how everything should appear. So we didn't need this flexibility. And we actually have our own styling, which doesn't always look like material. So if you want to save some time on the development, maybe you can just wrap material design with your own parameters, like this. Basically, create your own button, apply the styling to material button, and say that it's your button. It's a doable approach, but it has some downsides. For example, we used to have material design. Now we have material design 3. Who knows what happens in a couple of years? Probably we are going to have material design 4. But as you can see, they are significantly different in terms of UI appearance. And it means that if you want to wrap your button, and for example, you did this a couple of years ago for Material Design 2, and Google released Material Design 3 and started to stop support Material Design 2, you have to do some migration. And it's basically not within your control that you plan the work, because Google just decided to release a new version, and you have to adapt your UI to the new version to keep them maintained. Another thing is that if you decide to wrap a material button within your button, it means that you have a lot of import conflicts. It means that you are going to have, for example, in your project, 3 buttons defined. One is yours, one is material, and one, for example, is not even Jetpack Compose, it's Android Views. So, what are the benefits and costs of this approach? Wrap and reuse already existing design system. First of all, of course, you're going to save a lot of time on implementation, but then you will have to fight the conflicting imports, spend time on library support and migration, and you need to support 2 teams, because material design doesn't have everything you need. You would still have to implement some custom components which does not exist in their design, so you have to provide some properties for those custom components too. And in comparison with this approach, the custom approach already doesn't look that bad. Of course, you have to pay the price ahead of time when you implement everything from scratch by yourself, but then you have complete control of the behavior of the components, of their appearance, and for the pace of updates. You modify them only when you really need them for your project. And you only need to maintain one team. And about those import issues, actually you can solve them pretty easily, and even if you don't even have a design system, you're on your own, but you could still just use this hack. Basically, if you have some imports which you don't want to exist in your auto-completion, you can just remove them from IDE settings and leave the ones that you just need. Okay, we decided to build our own custom design system because material doesn't meet our needs. How do we do it, and what are the good things and bad things on this approach? How do we create the perfect component API that makes a lot of pleasure for developers to use? Let's take a look at the case of the buttons. So, in our project we have multiple button styles. So it could be primary, secondary, black, white, semi-transparent. And to define all those variants in the code, we can do a different approach. The most default one, straightforward, that comes to mind first would be the enum classes. So we have an enum class called button type, which describes all the variants of the buttons which we could have in our design system. Then, in the component API, we provide this button type as a parameter. And then within the button implementation, we map this type to a specific style property. Yeah, style property. So in this case, blacks maps to black token, primary maps to primary token, etc. So this allows us to have all the implementation inside. Developers don't really need to know about which tokens to use. They just say the type and here we go, it works automatically. But it's not very extendable. And also kinda pollutes the type, because if you have really many types, it's going to be a very long when statement. And to address it, we could try a different way of doing it. For example, for each button type, we're going to have its own composable function. And to do this, first we need to define the base button. Basically, it's a composable function where you can pass all the configurable properties of your button as parameters. So in our case, background, content, color, etc. And then you create a composable function for the black button, and another button type, and another button type, where you just pass all the same tokens which we used in the previous when statement for enums, but you pass them as a parameters, and instead of using generic button and passing the type, developers can say they're using just a black button always. This is a pretty nice approach. It's cool to use in the code, but it has its own costs for the scale. If you have, for example, 40 button types, it's going to be 40 composable functions, and it's going to be crazy in the imports. So, what do we do about it? We can use a very similar approach to the text styles implemented in Compose. We will call it styles. And for this, first, because Compose doesn't have a button style class, we have to define it ourselves. Basically, all the same parameters which we discussed before, but in the data class. We provide it as a parameter to a button function, and then the same we did on the design system level with the text styles. We create a data class which all describes all the default button styles which we have, and we provide it with the team later to use. It's, I would say, one of the best approaches that could be, because we provide the convenience of use for the developers. We already have all the values predefined for them, but at the same time, if something comes that designer decided to create a super nice premium feature, extra cool design that makes all users want to pay and give them all their money for us, developer can create a custom style in place when they really need it. So it makes all the use cases consistent, but gives enough flexibility when you need it. So let's compare the differences. Of course, Enum has a closed implementation, so it's super hard to extend by developers. You just need to add a new type, you have to modify the code of the component. And you don't have a ability to customize in place. But it's nice that you will always have the use right tokens, because they're mapped within the component. Very similar case for the composable approach, and style has most of the benefits, but has small costs. Is that basically if you have too many styles, the data class is going to grow. But I think it's reasonable, and another thing is that could be abused in this approach is that developers could start to implement too many custom styles. And then it just becomes chaos because it is not directly attached to your design system. But in our approach, in the company, we have enough trust into the designers and developers that when we provide them some default and ready-to-use tools, they go the easy and the right approach and create some custom only when they need it. So, what could be the lesson learned from this whole journey of trying different ways? I would say that when you implement the UI, it doesn't even have to be the design system or even some projects, any code, anything you write. Don't always go with the first solution. Try to experiment. Try to build some proof of concept and see how it uses, how it works, how it could scale in the different scenarios. Try to build multiple things and see which one is best. Don't always go with the first feeling. Okay, we built the design system, but we need to maintain it somehow, and with time everything goes to chaos, so we need testing for it. Testing is actually pretty easy in this case, because Compose provides us very useful tools called previews. Basically, you can just write the code, put some annotation onto it, and then in the Android Studio, on the sidebar, you're going to see your composable function running. And it's very nice, and showcases the design. And also, for example, when developers write some features with your components, they want to use a button style, so they command click into the code for the button specifically, and there we go, they have all the use cases as a previews, so they can just see how it works and do the same in the feature code. It's very nice. It's like documentation and code combined into one thing. And while working with the previews, we usually follow such strategies, and that for one component variant, like we did with the buttons, we do one preview. It's pretty easy. And when we work on the feature screens on a larger scale, we usually make one preview per screen state. For example, we have a loading screen for the state and success. So we are going to have two previews. And of course, with such a thing, we can just apply different themes. And for example, if you have multiple apps or dark and light theme, you can also do the same for them. It's pretty easy. And we also do the accessibility testing, and we apply different font scales for those same previews. But previews are only working in the Android Studio. You cannot run them on your continuous integration server and notify you when something on the UI changes and you need to validate the UI changes. I mean, it's pretty easy to solve. We already have solutions for the screenshot testing. As you can see on the snapshot, this is how the result looks. Basically, we had one screen, we took the picture of it, saved it somewhere in our codebase. Then on the continuous integration, some changes happen. We took the picture again, and they are not the same anymore. So we show this difference to developers and say, decide what happened here. You have to investigate and see whether it is expected change or not. If it is expected change, we just say, okay, we apply the new screenshot, now it is the new default, continue to work. And as a libraries which we can use for this solution is Roborazzi and Paparazzi. They are very convenient because you run them on JVM instead of Android emulators, so they run very quick. For example, in our codebase we have like thousands, around 4,000 snapshot tests for design system, and they run in 2 minutes. If you try to do the same with the emulator, it's going to take around 15 minutes, very long. But with this, you can iterate very quickly and validate your changes. But for some scenarios, we still do the on-device snapshots. So we have a smaller amount of the tests which are end-to-end tests, and within them we validate the whole app UI. So we make sure that it works correctly, and also with the on-device tests, we can also do the localization changes, testing. So we can take screenshots of different locales. And small tip for using the previews, you can actually save some time on you using this strategy called multi-preview annotation. Basically, in Compose, you can put a preview annotation on some composable function, and it's going to show you in the IDE. But you can put more than one, and then you combine them and make them reusable. So in this case, we do a font scaling annotation, and instead of trying to write two previews with different font scales, we can write one preview, and then it will generate two screenshots with different font scales, like we see on the pictures. And the last step, but the most important one, is automation. Because so far we write the code by ourselves on the client side, but automation allows us to generate most important things and streamline the steps from the design to Android developers and iOS developers and everything else. So, how does our automation pipeline look like? So we have designers in Figma. They're configuring a component, defining all the tokens, all the properties of it. Then we have this tool called Token Studio, which basically exports all the tokens from Figma into large JSON file. And then we have our own custom implementation of the compiler, which transforms those tokens, this big JSON, into platform-specific code. So for example, for Android, it would be XML resources with all tokens defined. And for Jetpack Compose, it would be those product token classes we see before. We don't have to write them. Manually, we generate the code for them. And then on the Android project side, the only thing that we need to do is to run a Gradle task which pulls up this code and puts it in the right place. And here we go. You have an updated version of the design system. So, to align all of this, developers don't even need to go into the project and press the update. We have like our internal utility UI, where you have a button which says update the design system. And it does all the updates for you, commit the code, run the tests. You just need to make sure that nothing is broken. That's it, very easy. And the main benefit of it is that there are no manual steps involved. Everything is automated, which means that developers using your design system pipeline, they don't really need to know what happens inside. They need to be aware. They just press a button and they have the latest tokens, the app UI is updated, or they have the new tokens to use in the code. And it directly connects the designers and developers. So the designer can tell developer, I have updated, added new thing, and the developer will just update them on the client side using automation, and there we go, all automated. And there are no space for mistakes because everything is done by robots, not us. Because it's so easy to use and convenient, you can use it very frequently. So when each update comes, you can just press the button, and there we go, you already have everything in place. And of course, it keeps the consistency because you don't have to write it manually. So all the names are derived from those JSONs defined, which means that the same thing are named the same on the different platforms. And I think, yeah, that's pretty much it. This is how we set up our design system. To conclude, I would say that the design system is kind of like an architecture. The best one is works for you. Oh, okay. So don't blindly follow someone else's path. Talk to your designers, see what are the needs of your projects, and create it yourself. That's it. Thank you. If you have any questions about Compose, UI, I'm ready to answer.
Thank you so much for the interesting talk. I have a question regarding tokens and composition locals. So when we generate them, so we have some tokens, and you said that it's not a DI framework, it's not compile safe, but how to make them compile safe? Because we still have this unsafe way for these tokens, for using these tokens, not for dependencies, but actually it is a dependency. So is it possible, or did you try in your company to make it somehow compile safe? Or maybe some linting or anything else?
No, we do not. To make sure that it doesn't fall through on production, as I mentioned before, we have end-to-end snapshot tests, which would validate if we set up the tokens in the wrong way. But overall, no, we don't have this compile time safety still. But what we do is that just we limit the use cases. So for the design system developers set up the teams and everything, the right values once in the project. So everyone else involved doesn't even need to know, because it works automatically and they need to set up. They don't need to set up it every time.
And for snapshot testing, it also composition and locals are provided.
Yes.
So because they use the theme and you provide it on the theme level. Yeah.
Yes.
Yeah.
Hey, thank you for the talk. It was really great. I have like two questions regarding the Compose. So the first one would be, do you in your company use Compose only, or do you still the view-based layouts?
Okay.
And the other question is, since you mentioned the collaboration between the designers and developers, did you maybe try some tools such as Relay or something like that to connect directly Figma and Compose, or to generate? Yeah, you know what's Relay.
Yeah.
Okay, thanks.
So the first question is whether we use Compose only or we still use Android views. It's a hard question because our company is pretty large. We have a long history, so we cannot just say we rewrite everything with Jetpack Compose from now on. Views are no more. We still have quite a lot of UI code, but we have committed to Jetpack Compose adoption, I think a couple of years ago, once it was released and we decided that it was stable enough for us to use. So all the new features we implement with Jetpack Compose, and the old ones, when we modify them or decide to rewrite, we use Jetpack Compose for it. But if for something that's pretty old and doesn't need really updating, why would you care? Why would you do all this work for migration if you don't really need to do it? So we still use views and Compose, but Compose is preferred way. And this was the first question. And the second question is about using this Relay tool. I know what it is. It's basically we have this first step of design system automation where we generate only tokens. But what this Relay tool does is designers define some layouts and whole screens on Figma, and it allows you to generate some Compose code which is going to be implementing such screens. And we have experimented with this project, but we are not using it because I would say it's quite unstable and basically costs more to fix the mistakes that it makes rather than just writing the code straight ourselves. And writing the code when you have all the components ready is pretty easy already, so we don't use it. But we do some experiments to make it work, but still not yet. We don't use it in production.
Cool, thanks. Yeah, we're also trying to investigate in that direction. That's why I asked. Thank you very much.
Any more questions? Okay, I guess that's it. Oh, there you go. Yeah, sorry.
What is better that create UI design by Figma and export it as image and crop it, or take it like code? I mean, convert it like you told us before. Take it as a code or export it as image.
So, if I understood correctly, you're asking about the icons, yes?
Yes.
Okay. We have icons in Figma and we export them, but we don't use the code. We export them as Android vector drawables and then use in the code base. But overall, the pipelines looks very similar to what we did with tokens. Basically, they are defined on the designer level, and then we put them automatically into the code base. So developers will going to have access to all the icons in our projects ready to use from the automation. They don't need to copy manually. Oh, we have another question on the front row here.
Hello. So you mentioned about snapshot testing.
Yeah.
So do you actually use Figma Figma designs which the designers use for snapshot testing, or do you actually run some default? You run the app and then you take that as the baseline and you match it with that.
Mm-hmm. Okay. Yes. Answer for the second part. Basically, we don't use Figma as a golden standard for the snapshots because, first of all, designers usually create UI for the iPhone, as we all know, probably. So it's not going to be really the same. And also, what we do with the snapshot testing, we take different sizes of the screens and different font scales, but designers don't do it. So we don't have all the properties to compare with Figma. So basically, yeah, we just take the snapshots when developer decides that feature is ready, it looks perfect, it compared with Figma by all the properties, designers looked at it and said, yeah, it looks great as we wanted to make it look. And then, somewhere in the future, if the code changes, we are going to have the validation that new UI has appeared, and we are going to see the difference. So, yeah. Okay.
Thank you so
I
much.
think that's it. Thank you very much.
Thank you so much. Thank you so much. Appreciate it.